Hello, my amazing students. This is Mrs. A here with the very last section of intermediate algebra. So we're doing 10.2, which we're going to start with the development of the quadratic formula. Now remember that our quadratic equation has a standard form, and the standard form is ax squared plus bx plus c equals 0. So in developing this quadratic equation for you, I am going to start with this generic standard form of the equation with the a, b, and c being variables, just like you see it in your textbook. And I am going to complete the square, always doing the same thing to both sides of the equation till I get to the quadratic formula. It's really cool, okay? So remember that if you can do this on a piece of paper for your final exam, what you have to do is come up to me at the end of your final exam, get a piece of paper that I have already initialed, and then develop your quadratic formula on it. Pretty nice, huh? All right, so this is extra credit on your final. So here we go. The first thing we're going to do is get it ready to complete the square. Remember, my constant needs to be on the other side, and this first term, my x squared term, needs to have a 1 coefficient. So that's what I have to work on first. So I'm going to have ax squared plus bx on the left, leaving a space to complete the square, subtract c, subtract c. So I get a negative c on the other side. And then, because I can't even complete the square till this is a 1, I'm going to divide by a, and divide by a, all the way across. And now this is a 1x squared. So I will just go ahead and make it a 1x squared. And now I cut this one in half. Remember, when I cut it in half, I multiply the denominator by 2. So I end up with b over twice a. Okay, b over a is the coefficient. b over 2a is when I divide it by 2. And then I take that number and I square it. So b squared is b squared. And 2a squared is 4a squared. 2a quantity squared. Okay, so I can't just add that to the left. I must come over here and add that to the right too. So b squared over 4a squared on the right as well, so that I'm balancing and never doing something to one side that I don't do to the other. So now I'm going to, again, drop this variable down here, and I'm going to check. This should now be a perfect square trinomial, and now I'm going to check and make sure that I properly expressed it as factors. So the first term squared, this product doubled. We'll get rid of the 2 in the denominator, the last term squared. So now on the right, I have negative c over a plus b squared over 4a squared. But remember, I want to have a 4a squared in the denominator. So let's just come over here. If I took c over a and I were trying to get it as a common denominator, over 4a squared, what would I have to multiply a by to get 4a squared? 4a, right? So basically what I'm doing is I'm multiplying by 1 in the form of 4a over 4a to get 4a squared on the bottom and 4ac on the top. So 4ac is the top. So this one right here, this negative c over a, I'm going to change it to negative 4ac over 4a squared, so that I have a common denominator with this other part that I have over here. So now I'm going to erase all of this. So now I have this left term squared. I have a binomial squared, and on the right, because they're both over 4a squared, I'm going to flip them around and put the b squared in the front, b squared minus 4ac. Those of you who know the quadratic formula are beginning to see some things that are looking like they're heading in that direction. So now I've got something squared equals something else, so I'm going to take the square root of both sides. when I take the square root of the left and the square root of the right, I'm not going to forget my plus and minus. This one comes out and is x plus b over twice a equals plus or minus the square root of b squared minus 4ac. Now I'm going to split this square root, this big square root, into two parts, because if I write the radical on the top and the radical on the bottom, then the radical in the denominator is going to come out of the radical, because 4a squared are perfect squares. So it'll come out as a 2a. Last step. So now I'm going to subtract the b over 2a. And I'm going to subtract a b over 2a right in front of my plus and minus. And my final answer is x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And because I have a 2a and because both of these parts are real, I may write all of it over one nice long denominator. Negative b plus or minus the square root of b squared minus 4ac over 2a is what x will equal. This is your quadratic formula derived for you. So if you would like to do that for your final exam, you get a little bit of extra credit. Okay, so now we're going to use that formula. So remember that that was x, but it's going to work for any of our variables. So g is equal to negative b over plus or minus the square root of b squared minus 4ac all over twice a. Now, when I look at this is in standard form. A variable squared plus b variable plus c equals 0. So a is 4. B is negative 2. And c is negative 7. So these are the numbers that I will plug in to this formula. That's all the quadratic formula is. It's a plug-in. Okay, so g is negative b. So since b was negative 2, negative and negative 2 will be a positive 2. Plus or minus the square root of b squared, which will be 4. Minus 4 times a was 4. C was negative 7. All over twice a, and a was 4, so twice a. So now we wind up with g is equal to 2 plus or minus. Now, this whole back side here is 3 products, 3 things multiplied together. A negative times a negative is going to be a positive. And I have a 16 times a 7, which is going to be 42, 112. So I wind up with 4 plus a 112. So I'm going to have square root of 116, all divided by 8. So I have an 8 in the denominator. That doesn't look like an 8, but that's an 8. And then 116, if I factor it, does factor by 4. Okay, so that's going to be 29, I believe. Let's see, 9 times 4 is 636. Yeah. So divides by 4 with 29 left over. 29 is prime. So my answer is going to be 2 plus or minus. Now the 4 square root of 29 is going to be in the radical, right? So square root of 4, square root of 29. The square root of 4 becomes the 2. Square root of 29 divided by the 8. And so these are all out of the radical, so a 2 and a 2 and an 8 can simplify. So my final answer should be 1 plus or minus the square root of 29 over 4. So let me write that down. G equals 1 plus or minus the square root of 29 over 4. And I'm going to check that answer right now and make sure that we got it right. While you're looking at, yep, that is right. 1 plus or minus the square root of 29 over 4 winds up being the correct answer for that one. Okay, so now we move to the second one, which is y squared is equal to 6y minus 25. And this one is not in ABC form yet. So y squared minus 6y plus 25 equals 0. It's important for us to get it in ax squared plus bx plus c form first. So now you can see that our a is 1, our b is negative 6, and our c is 25. Okay, so now when we write down y equals negative b plus or minus the square root of b squared minus 4ac all over twice a, and I start to plug in. So negative b is going to be a negative 6, so that's going to be a positive 6. Plus or minus b squared is going to be a 36 right here. And then the 4 times the a, and the a is 1. And the c is 25. Okay, so over twice a, and a was 1, so twice a is just 2. Now notice what happens here. 36 minus 100. We're going to have a negative number there. So that's going to mean we have the square root of a negative, which is going to be an imaginary solution. So we wind up with 6 plus or minus 36 minus 100 is a negative 64 all over 2, okay? But the 64 is going to break up into the square root of negative 1, the square root of 64, which is 8i. So we're going to have y equals 6 divided by 3. Since I've got a real part and an imaginary part, I'm going to separate them. So 6 divided by 2 is 3. Plus or minus 8i divided by 2 is 4i. Okay, so we have a 3 plus a 4i and a 3 minus a 4i, and those are correct solutions. Okay, we have one more problem to go before we go into the discriminant. So this one, it's going to take a little bit more work because it is not in the right form. So we're going to FOIL this, and we're going to get 4d squared. First, outside is negative 6d. Inside is 10d. Last is negative 15. Okay, and now this 2d plus 1, I'm going to move to the other side. So minus 2d minus 1 equals 0. Okay, so I'm getting a 0 on one side. So let's clean all this mess up. We get a 4d squared plus 4d, 10d and a minus 6d is a 4d minus the 15 and the 1 is a minus 16. And let's go ahead and take that minus 2d out of here. So that's going to be a plus 2d equals 0. So now, can I divide everything by 2? Okay, so I'm just checking my math here, making sure it's right. It's looking good to me. So I'm going to divide everything by 2 and get 2d squared plus d minus 8 equals 0. So my a is 2, my b is 1, and my c is negative 8. Okay, so now I plug in. So d is negative b plus or minus the square root of b squared minus 4ac all over twice a. Okay, so negative b is going to be negative 1, so let's take off that, negative 1. B squared is going to be a 1. And times 4 times a is 2. A is 2. C is -8, and then A is 2. Okay, so now underneath, we're going to call this underneath there is going to be the discriminant. We're going to talk more about that in the next section. But -4 times a -8 is a +32 times a 2 is a 64, and 1 plus a 64 is the square root of 65. So this whole thing becomes -1 plus or minus the square root of +65 over 4. Okay, -1 plus or minus the square root of 65 over 4, and that is a correct answer. The correct answer. So D is equal to all of that right there. All right, so we're done for now, but I'm going to come back with the second half of 10.2 because I have to go teach a class, one of yours. And then we'll finish 10.2 and that will be it. So we're going to start next time with the discriminant to help us determine the number of solutions that we should have. And this is Mrs. A, and may God bless you. All right, my students, I am determined to finish this video as it's the last one. And some of you are going to need this material because you're going to take your Connect Math final this week. And so in order to make sure you get the material, I'm going to get this link out there very, very shortly so that you have everything you need to do your very best on that Connect Math final. So we have a few more problems to go and we will be done with the whole thing on the quadratic formula, which we've already derived. Now we're going to talk about a very special part of the quadratic formula, which is called the discriminant. Okay, and first of all, here is my quadratic formula again. X is equal to -b plus or minus b square root of b squared minus 4ac over 2a. Now, if you are looking at this formula, which I hope you are, this little part right here underneath the radical has a special name, the discriminant. And because it is the discriminant, because it helps us to know what kind of a solution we're going to have. Would you agree that if this part underneath the radical was positive, then we would have a real solution? And if the part under the radical was negative, then we would have an imaginary solution, which we would have to use complex numbers to represent. If this part that is under the radical, the discriminant, is positive and a perfect square, then won't this entire thing come out of the perfect square and be able to add and subtract with whatever negative b is? Okay, so that would be not only a real solution, but a rational solution. Okay, so the discriminant is not the radical itself. It is the part that is underneath the radical. B squared minus 4ac, the part under the radical, is the discriminant. Okay, so we're going to use this discriminant to determine the types of solutions and the number of solutions that we're going to have. Now, I have told you that in a past life, long time ago, I was a programmer out on the base and I programmed missiles. Okay, so if I had a missile that was going up and coming down at a certain spot, wouldn't I want a very definite real solution for the spot where it's going to hit the ground? In other words, missile ballistics is no place for imaginary solutions at all. Okay, we want real definite solutions for missile ballistics. However, if we were dealing with electricity, heat mechanics, wave mechanics, anything to do with energy, we might expect some imaginary numbers in our solutions. And they're perfectly good solutions for energy type situations. So those would be expected and correct for those types of situations. So if I was a missile programmer, I would want to make sure that I wasn't coming up with imaginary or complex solutions. Okay, so I could check my discriminant, which is b squared minus 4ac, the part that is underneath the radical. I could check that for whether it's positive or negative. If it's positive, then I'm good to go, because I can be assured that I have a real solution to my quadratic equation. But if I am an electrician, I would be okay with complex solutions. So if this value of the discriminant is positive, okay, then we will have two real solutions. Okay, if what is underneath there is negative, then we will have two imaginary, we'll just write complex, okay, two imaginary or complex solutions. If the part that is under the radical or the discriminant is 0, then this whole thing would go to 0, and we would have plus or minus 0, because the square root of 0 is 0, and we would end up with just one rational solution. One rational. Now, of course, if it's rational, it's also real. Okay? And if we had positive and a perfect square underneath the radical, then we would have two real but also rational, because it would come out of the radical. So if we had a perfect, it would be irrational. If we had just a positive, it would be real, and we would have two of them. The only time we have one solution is when we have a 0 as our discriminant. Okay, so looking at the discriminant is a very important tool for us knowing what kinds of solutions we will be coming up with. So here we have an equation, and we're going to evaluate the discriminant of this equation. We're not going to solve the equation. We're just trying to find out what types of solutions it would have. Is it going to have real solutions, imaginary solutions, what? So we're looking at b squared minus 4ac, okay? And our b is 3, okay? So b squared would be 9. I got to get a new marker here. 9 minus 4 times a, which is 1, times c, which is negative 9. All right, so now notice that I've got negative 4 times a negative 9, which is going to be a positive 36, and 36 plus 9 is 45. So I have a 45 discriminant, which is positive, but not a perfect square. So I will have two real irrational solutions. Okay, they're not going to be rational because it needs to be a perfect square to do that. So they're going to be two irrational solutions. Two irrational. Okay, and I'm going to get another marker. All right, so there's another look at that board. Okay, we had two irrational solutions, and I've got another marker to make it a little bit easier to see. And now we're going to do another problem. We're going to find the discriminant of this equation, and it is not yet into its ax squared plus bx plus c form. So we're going to turn this around, and we need our c squared, and then our c, and then our constant. So 11c squared minus 9c, because I'm moving it from the right to the left, plus 6. Again, moving it from the right to the left, I changed the sign. So now I have it in the correct form. So now my a in my ax squared plus bx plus c is equal to 11. My b is equal to negative 9. And my c is equal to 6. Now remember, I'm not trying to solve this. I'm just looking at my discriminant, which is b squared minus 4ac, the part that is under the radical. So b squared would be 81 minus 4 times a is 11 and c is 6. Okay, so I wind up with 44 times 6, and 44, I'm trying to get that shine out of here. 44 times 6 is 24, and 24, 25 to 6, 264. So we have 81 minus 264, which is going to be, let me just do 264 minus 81 because that's easier. And that's going to give me a 3, and a 25 minus 8 is a 17. So I have a negative 173, okay? And negative 1, oops, I must have done something wrong because they said, oh, I didn't borrow there. It's 183, negative 183. Sorry about that, math error. I didn't need to borrow. So negative 183 is the discriminant. Since negative 183 is the discriminant, we're going to have a complex number solution, okay? Complex number solution. So those are not real solutions, and we will have 2 of them because we have a plus and minus in front of that negative radical, okay? So that is the second problem with the discriminant. And now, for the last problem in this set, we have a word problem. Okay, so we have a ball is thrown upward from a height of 20 feet. The height h of the ball in feet, t seconds after the ball is released, is given by h is 16t squared plus 4t plus 20. So I'm going to write that equation a little bit bigger over here. H is 16t squared plus 4t plus 20. So they're not making us come up with the equation. They're giving us the equation, and they're saying height is the height of the ball, and t is the number of seconds after the ball is released. So question A here says, how long does it take for the ball to reach a height of 8 feet? Okay, so here I am tossing the ball up, and it is, correction, a negative 16t squared. I had a miscopy. I just looked at it on the paper. So it's a negative 16t plus 4t plus 20. Now let me just show you a little bit about these equations. All right, when the ball is released, it's going to go in an upside down parabola shape, okay? So here the ball is released, and it's going to go this way. Now, with that being said, will the ball possibly be 8 feet twice? We don't know. If 8 feet is not the highest spot right here, then maybe that's 8 feet, and then wouldn't it hit 8 feet again? So 2 places that it could be 8 feet, unless 8 feet is the very, very top of my parabola. Okay, but this negative 16t squared is a parabola upside down. Anytime that first term is a negative. So I'm looking for a height of 8 feet. So I'm going to put h is 8. Okay, h is 8, and I'm going to solve this parabola. Okay, so first of all, I need to get, since it's quadratic, I need everything on one side with a 0 on the other. So I'm just going to subtract the 8 and subtract the 8, and I'm going to get, let me erase my little parabola here. I'm going to get 16t squared plus 4t plus 12 equals 0. Okay, so I have it set equal to 0, and the first thing I would do is I'm going to divide everything by 4, because remember, I can divide both sides of any equation by a non-zero number. So if I divide everything by 4, I'm going to get 4t squared plus t plus 3 equals 0. Okay, so then I look and I said, does this factor? Well, it probably doesn't, because it is in my quadratic formula. Okay, and if I look at it, let's just see. I just realized I forgot to bring down my negative sign again, and since I have a negative sign on the front, I'm going to go ahead and multiply both sides by -1, because I never like to try to factor something when I have a negative on the front. So let's just multiply everything by -1. 4t squared minus t minus 3 equals 0. Now this thing might actually factor. Let's see. So when I factor it, let's see, if I put a 4 and a 4t and a t and a 3 and a 1 and a negative and a plus, do I get, when I FOIL it, do I get back to here? Let's do it. 4t squared, 3t minus 4t is a -t minus a 3, so it does factor. Okay, so now I set each factor equal to 0, and I end up, when I set that equal to 0, 4t plus 3 equals 0, I get t is a -3/4. Okay, and t is a -3/4, is going backwards in time. Okay, and that's not going to work for me, going backwards in time. But t is equal to 1 is the correct solution. Okay, t is equal to 1 is the correct solution. So this thing is going to hit 8 feet one time at t is equal to 1. We only have one real solution to that one. And then we have a part B to this problem. And the part B to the problem says, how long does it take for the ball to hit the ground? Okay, well, remember my formula is h is -16 t squared plus 4t plus 20 equals h. Okay, now if it hits the ground, that's ground 0. So we're going to put a 0 here for h and find out how long till it hits the ground. Now again, it's quadratic. It's going to hit the ground. It's going to have two solutions, but only one is going to be workable for us. Okay, so we're going to, again, since I have a negative and I have a 4 in each thing, I'm going to divide by a -4 and put my 0 on the other side. So when I divide this by a -4, I get a 4t squared. I divide this by a -4, I get a -t. Divide this by a -4, we get a -5 equals 0. Okay, so because I have opposite signs and I have a -t, I'm going to get a 4t and a t. Okay, we're going to get a 5 and a 1 and a negative and a positive equal to 0. Right, so I get, when I FOIL, that works. Okay, so these were factorable. Even though they were in the quadratic formula section, they were factorable. So then this one is going to, when I set it equal to 0 and that equal to 0, I get t is -1. Again, that's going backwards in time. And then I set this one equal to 0, and I get t is 5/4, which in seconds would be 1.25 seconds. And that is the correct answer. So 1.25 seconds is correct. And let's go back just so that you see what's going on in this. Okay, if I go back and look at what's going on here, this guy is throwing a ball. Okay, he's releasing it from his hand. And I'm great at stick people here. So here's the ball. And he's throwing the ball, and it's going to hit the ground. Okay, so it's going to hit the ground in 1.25 seconds. But notice that if he just threw it behind him, the ball would fall on the ground this way too. Okay, so it would take it 1 second to hit the ground backwards, but we're not interested in what it's doing backwards in time. Okay, so that's why there's two solutions though, because the parabola that is used to model the equation would hit the ground on the other side of the guy who's throwing the ball as well. Okay, so that's just a cool little application problem. In that one, we did not have to use the quadratic formula to do those, but we could have found that there were real solutions for that one. That is the end of our quadratic formula and the end of all of our videos that we will need to do for intermediate algebra. And I hope you will look me up again, because I'm trying to put college algebra out here online next. So even if you don't have me for your teacher, you might be able to find some really cool, helpful videos for college algebra in the future. So this is Mrs. A, and may God bless your day.